Hello, folks. First of all, thank you for showing up, and thank you, Eventual and Daft, for hosting. It's really awesome. I'm Stu. We're with 12 Labs. 12 Labs, inspiring. We're building video understanding, video search, and video language modeling. So, any of that sounds cool, please come chat with us after the talk. With that, we'll dive right in. I, of course, skillfully did not read out the title of the talk, but we'll be chatting about, if you're building distributed data tools, as some folks in this room definitely are, what are some things that you should think about to make, your future users happy? So this talk will be inspired by our recent work, prototyping Racer. So distributed data tool, running for all of the fun distributed data challenges. And the premise of this talk, the whole reason we're here is I encourage you, developers of distributed data tools, to really consider local development to be P0, right? It's wonderful if your tool works for petabyte scale, exabyte scale, whatever the next thing is. But if it doesn't work on my laptop, I'm just thinking about I just want it to work on my laptop so I can prototype things so that I can get a sense for, is this the right tool for me? And you can do like other cool projects, like some of the cornerstones of today's ecosystem, like Torch, really have this built in. So if I run a data loader with 10 jobs equals 1, just works. It's not forking anything. There's no processes. I can put a debug statement in. Everyone's happy. Looks great. Look around. Very helpful. Another great tool that I want to highlight is JobLib. JobLib, I guess, isn't as cool anymore in the AI age, but it's used very heavily by scikit-learn and makes it very easy to parallelize user code with the same principle in mind as PyTorch. And I already alluded to this, but when you are building your tool, please make sure that PDB works. I just want to be able to put a breakpoint in my code. You can have some local mode, right? I'm not saying your distributed tool has to stop on, 45,000 servers at once. But on my laptop, I put a breakpoint in my code. It's like, please have some mode where that works. It's like some way that I can stop, look around, inspect. That is the essence of local development. Not just in Python, right? I could say PDB, I could say, pick your language, pick your debugger. But in order to quickly get to the root of many, many problems, print statements are not going to get me there. So they may work for you. You, developer of some hypothetical tool, that's great, that's awesome. But they are not the mode that everyone works in. So yeah, please keep debuggers in mind. And remember that, it's also critical for debugging your tests, right? Like if I have a test suite and a test fails, I should be immediately dropped into a debugger. If I'm not dropped into a debugger, if you've overridden it somehow, if you've clobbered it, if you've swallowed the exception, I'm going to be very sad. I'm going to be sadder than you expect. So please keep this in mind. This, I know, is a little bit hard to parse, but what you were looking at is my terminal. And you are looking at a running Racer application. Now, you might be a little bit puzzled because there appears to be a PDB breakpoint in my terminal, and that's correct. If I put a breakpoint in my user code and send a request that triggers that breakpoint, I actually get stopped in my terminal with this, whatever is happening here. And you really can type, at my prompt, you really can type stuff in, and something kind of happens. But needless to say, this was not the expected outcome. It would be great to be able to have things like, IPDB, pick your, favorite debugging extension, working here. I could search my debugger history. I could find things. I could look around. Here, yeah, it's one of those fun experiences where you hit the backspace and you get some strange control character you've never seen before. Not good. Please try to avoid this.
All right. Okay, cool. So switching over. Right. So orchestration is hard. Not what you'd expect to hear from the talk on Ray, but precisely which orchestration am I referring to? Orchestration, of course, we think about like scaling machines, distributing loads, distributing models, right? What about orchestrating your app logic? This is a pressing thing these days as we talk about building multimodal models. So if you were to go onto Ray's docs and look up kind of like as a hello world thing for Ray, right? You'd see something like this, where you've got this very nice separation of your Ray remote stuff, right? And the sort of a remote function that gets delegated through the Ray metaverse of gRPC and whatever. And then, of course, it just calls some other function, infer, which you can just test locally. And like to Stu's point, yes, models are big, yes, whatever, they run GPUs, whatever. You can still always, in theory, run these things locally, so you should be able to do that. Again, this is a virtue that we strive for and improves your developer velocity massively. Now, this is a very baby example, but in the real world, what we see is stuff like this. So as we sort of walk into the world of multimodal models, where we have a model and we take the output of that model and we feed it to other models or n other models, we now have this web of orchestration. And very, very quickly, this idea of sort of separating app logic from your Ray logic breaks down. And now, why make this distinction? Because as Stu showed before, when you start up Ray, and by the way, when you just call ray.get, Ray under the hood figures out whether or not a Ray has started, and if it hasn't started, it'll start one for you. You now fork a child process, you have workers, and all of this local development stuff is gone. Debuggers gone, understandability gone, and that is a really that's very burdensome when you're trying to build stuff. So one of the things that we've tried to do is split Ray apart from everything else, right? So that might seem like a contrived thing. Here's a very real example of at 12 Labs, where we run into this world where Ray injects itself unknowingly, very sneakily, into our app logic on accident. So we've got, you give us a video, we take a video, we sort of find some interesting scene boundaries, we take those scene boundaries, then we do some other stuff with them. Part of that other stuff is generating embeddings, right? But again, we don't have this clean separation of models. We have models that depend on each other. And it's exactly this paradigm that completely falls apart in a bad way. So, what do we have to do to get around this? Because again, we are persistent. We went back and forth for weeks or months on this, talking with the Ray devs and the NACL devs, and they were fantastically responsive to our concerns about this. We have to basically, at their suggestion and sort of our convergent understanding of the problem, come up with something like this. And if anyone here thinks this is reasonable, raise your hand. The point is, you basically have to start thinking about injecting remote Ray calls as primitive Python callable functions, etc., into your actual Ray orchestration logic. No one would think of this as a first pass. And it's precisely because of this idea that Ray forks itself and breaks apart remote development. We're very proud of this, obviously, but it's not something that you would want to do as an application developer. Cool.
So, I think talking about orchestration, talking about debugging, the third component really, and one that is very closely related to the first two, is principle of least surprise. What do I mean by principle of least surprise? What I mean is, consider this toy example. Here we have some Ray-serve thing. There's two models. Model 1 and Model 2, and 2 is the magic number, right? Like you have one thing, usually it works just like the docs say it should work. Then you have two things, and all of a sudden they didn't show you two things in the doc, they only showed you one. So what happens if you have two things? Here I have Model 2. Model 2 takes up Model 1, so I can instantiate a Model 1. Here I instantiate it with this bind call, that's a Ray-serve construct. And so I have this Model 1 and Model 2. Now you can see in the async def, in the call method, I am, delegating to Model 1. I'm delegating to Model 1's run method, and I'm delegating to Model 1 some instance attribute. Well, what happens here? What happens here? It's an interesting question, Paul. What happens is, you see I passed Model 1 a deployment handle to Model 2. Well, now it turns out that every instance attribute of Model 1 is also a deployment handle. this was an unexpected development. I can't multiply a deployment handle and an int. Okay. But why did my integer get turned into a deployment handle? I get my method, like, you know, my method needs to be proxied for this remote, you know, fancy distributed data thing that I hear about. But did my int need to be proxied? I'm not sure. But I encourage you to ask questions your users would ask. Are your users going to wonder what happens to their integer? If so, consider what you can do to save their integer.
I just want to add to this. You might wonder how this stuff comes up. And of course, this all comes up naturally as we're building out these apps. Imagine you have metadata sitting on your model, right? And of course, we're talking about, again, an integer. You wouldn't think as a developer that I have to access an integer via a remote proxy call through gRPC across, you know, whatever server. And so again, these are things that just naturally come up, and then this kind of stuff happens.
These are all real problems, by the way. These are contrived. We hit every single one of these mines.
Painfully.
And to just hammer that point, it's like, you are going to have some really cool API that you developed, and you know it really well because you're developing it. But your users are going to come in knowing nothing, sometimes less than nothing, as we demonstrate. Deployment handle. There's the serve.deployment decorated ethics cool. There's applications. At some point, deployment handles actually turn into applications at runtime. It's not like a static thing. You keep it simple. These may genuinely all be required for Racer. May legitimately be the case. But when you're developing your application, just make sure. Just make sure. And one final note is, you know, we've shown some silly things that happened along the way with, you know, Ray and Racer. But we actually really do like Ray. It's a great tool. It has a lot of strengths. Any tool is going to come with challenges. Some of them will be building understanding. Some of them, you know, may have legitimate quarrels every now and then. But we really do think Ray is a great tool, and we really think that any scale team is super awesome. As Paul alluded to, you know, we've chatted with some of the Racer devs a number of times about issues, you know, that we ran into, and they've been really helpful. Clearly articulated like why things are the way they are, what are some, you know, remedial steps that, you know, they can take and are interested in taking in the future to help out, you know, people like us coming in, not knowing what we're doing. So this isn't meant to bash on Ray or Racer, but frankly, I think Racer is the best option in its category. But there's always room to go.